Good morning, everybody. Happy Tuesday. Jumping into another video about the slope-intercept form. So that's the y equals mx plus b. And yeah, I'll jump into a lesson today, a little bit of homework, and that is it for this Tuesday. Here we are, page 563. And here it says we're writing an equation using y equals mx plus b. I'm just going to say this is where we use the slope-intercept form, y equals mx plus b. Okay, so just a reminder, right? If we have this form of an equation, y equals, and then I have something times x plus my constant at the end, well, that slope, m, is the coefficient on x. I have that, it's great. The y-intercept is my b value. Okay, that's where I cross the y-axis. So if I have m, I have b, I have the equation of the line. Okay, so what I can do with that is, all right, if I have class example 1, write the equation of the line passing through the point 0, 2. Hey, well, wait a minute. That's a y-intercept. X is 0, y is 2. That's a y-intercept. And what that tells me is that b equals 0. B equals 2. Sorry, x is 0, your y value is 2, so the b value is 2. And then it tells me the slope is 5/2. Okay, well then m equals 5/2. So I normally wouldn't do this, but the equation I'm looking at is y equals mx plus b. The equation of a line can be written in that form. I know the slope, I know m, it's 5/2. So I replace the m. And then I know the b value, it's 2. So I'd write plus 2. And there you have it, the equation of a line. And I'm done. Okay, that's all it takes. If I want to write the equation of the line, now that I know slope-intercept form, find the y-intercept, find the slope, boom, you have your equation of the line. Okay, so let's look at line 1 and line 2 down below. Okay, maybe I'd give you the slope and a point, or the slope and the intercept written as points. Maybe I just give you a graph and I say, well, what equation actually represents this graph? So for line 1, okay, what I need is two things. I need the slope and I need the b value. And as soon as I find those things, I'm good to go, right? As soon as I find those things, I am ready to roll. I can write the equation of the line. So I find it actually easier to find the y-intercept first. So for line 1, L1 over here, that's this one. It crosses the y-axis at -4. The point would be 0, -4, where my b value is -4. Okay, great. I found the one piece I need. And now I need to find the slope. I need to find the other piece. Well, maybe I have to find 2 points and I use the slope formula. Or a lot easier, why don't I just find a second point and then look at rise over run? Okay, so got my first point. And then what I'm looking for is another one that lines up perfectly in the crosshairs. Okay, so no good, no good. Oh, right there is a good point. No good, no good. Oh, another one that's good, right? Maybe I go back the other way. Oh, that's a good point. Doesn't really matter. I'll pick this one. I'm just picking 2 points that actually go through the crosshairs, and then I can say slope. Well, you go up 1, so rise of 1, run of 3. Rise over run would be 1/3. 1 over 3, right? Okay, well, if I have my m and my b, if I have my 2 pieces, boom, click them in.
Boom, click and go back this way. Boom, here, click and go that way. Boom, that way. Click here and go back this way. Boom, that way.
Right? I just put my pieces in. Y equals mx plus b. Y equals 1/3 x plus my b value. Well, it's a negative, so -4. Right? Find these 2 pieces. That's it. Then boom, click, plug them in, and you're good to go. All right. Let's do L2, or the second line on this graph. Okay. You can do that one ahead of me. So pause the video and do that one ahead of me.
346 minutes later.
Okay, hopefully you've got line 2 done a little bit ahead of me. I went ahead, I said, okay, well, if I'm going to find this thing, I need the slope, my m value, and I need the y-intercept, my b value. Went ahead and labeled that y-intercept. It's 2. Okay. And now I need to find another point that I could use to calculate my slope. Maybe I have 2 coordinates written and I use the slope formula, but I think it's a lot easier. Maybe this one. Okay. You could have picked a different point. I find another point and I count my rise over run. I fall 3 or down 3, so -3. I run 2. -3 over 2. So in terms of an equation, mx, or the slope times x, plus your b value. And there you go. From a graph, I can find the equation of the line if I can find the slope and I can find the y-intercept. Okay, that's fantastic. There we go. All right, moving on. It says determine the equation of the following lines. For the first one, it says the line has to be parallel to y equals 1/3 x plus 4. Okay, so that's like a different equation. I've got this 1/3 x plus 4. I want to be parallel to that line. And then at the same time, I want the same y-intercept as y equals 6x minus 7. So that's another line. So I'm kind of pulling my pieces of information. All right, well, I know I need an m value and I need a b value. So reading again, it says the line has to be parallel. My line has to be parallel to this line. I know parallel means the slopes are the same. So if this line has a slope of 1/3, my slope, or a slope parallel, would also equal 1/3. So there you go. I found my slope. And then it says if it has the same y-intercept as this one, I don't care about the 6x. I just care about the b value of -7. So mine will have a b value of -7. Well, there it is. I took the slope from one of the equations. I took the y-intercept from the other equation as it told me. And I can put it together. mx, so 1/3 x, plus b. It's a negative, so -7. There it is. I'm finding information. Found the slope from this one, found the y-intercept from the other one, and then I put them together. All right. B says a line passing through 0, 9 and perpendicular to the line joining 2, -6 and -5, 0. All right, well, I need slope and I need an intercept. Those are the 2 things I would need to find the equation of a line using slope-intercept form. I have my b value. 0, 9, that's a y-intercept. My b value is 9. Done. Found it. The challenge here is I have to find my slope. And I'm looking, okay, well, it gives me 2 points. And it says my slope would actually be perpendicular to the slope between those 2 points. All right, well, I can deal with that because I could find this slope. It's not given like the one above, but I have a slope formula. I can find the slope of these points, and then I could find a slope perpendicular to it. So that's what we're going to do. Okay, we're going to say slope equals y2 minus y1 over x2 minus x1. We're going to plug in. First point, x1, y1, make sure you label your points. Next point, x2, y2. 0 minus -6 over -5 minus 2. Your slope equals 0 minus -6 would be +6. And -5 minus 2, -7. Okay. So slope, -6/7, right? A positive divided by a negative is a negative. Well, I didn't actually want, okay, that slope. I want a slope perpendicular to it. And this is where parallel and perpendicular slopes, okay, parallel slopes, identical, they're the same. Perpendicular was the negative reciprocal, okay? So since the original slope was negative, perpendicular slope would be the opposite or positive, and then I need to take the reciprocal fraction, or bottom to top, top to bottom. There it is, okay? So had to do a bit more work to find this equation, but hey, I know a slope, I'm referencing, I find the perpendicular, and now I'm good to go. Y equals mx plus b. The slope I want is 7/6 x. The y-intercept I wanted was 9. There it is. Slope-intercept form is great because I only need 2 pieces, and I am good to go, right? I can find the equation of a line just with 2 pieces of information. All right, let's go into this one. Diagram shows the display from a graphing calculator screen. The intercepts are integers. Okay, good to know. Determine the equation of the line shown. Okay, well, if I'm going to determine the equation, I need to find the slope and the y-intercept. Okay, so let's take a look at this graph. Let's see if we can figure out some information. Maybe we label some points. Okay, it says your x minimum is 5, your x max is 30, your scale is 5, meaning every tick, 5, 5, 5. There's a space of 5 between all of these. My y scale, or sorry, my y minimum, -5. My y max is 20, and I have a scale of 7. So 7, another 7, and then the next tick would be off the screen. All right, well, let's label our intercepts. In terms of x, every tick was 5. So 0, 5, 10, 15, 20. That's the point 20, 0. All right. In terms of the y-intercept, 0, and my scale was 7. So 0, 7, 14. I line up perfectly on that next tick. So 0, 14. And that's actually my b value. Okay, I know that b is equal to 14. All right, well, now I need to find slope, right? I've got things labeled pretty well. Okay, I've got things labeled pretty well. Maybe, right, if I want to find slope, I have the slope formula. I could absolutely use the slope formula. Here's x1, y1, here's x2, y2. But I'm also looking at a pretty good graph, where I think I could just say, okay, from point to point, I go down, so -14, and I go over 20. -14 over 20. Maybe I use the slope formula to find that. Maybe I just count it, right? I know from 14 down to 0, down 14, 0 over to 20 over 20. And then, of course, I have to reduce that. So it's going to be negative. Those are both divisible by 2. And I would get 7/10. Okay? So I'll put that over here, -7/10. Well, there it is. Both of the pieces. All I need is those 2 pieces. If I want to write the equation now, I use slope-intercept form. -7/10 x plus 14. Good to go. Done. All right? So just another way for me to give you the information. Maybe it's on a graph. Maybe it's on a, maybe it's just a couple equations I'm referencing. Maybe it's whatever. All I need is those 2 pieces of information, and I'm good to go. Okay, last thing we're going to look at for this video, a little bit of a change of pace, still dealing with lines, just a little bit different. And this would actually be a review from grade 9. So this is something that we should have looked at in grade 9, for sure looked at in grade 9, but we'll revisit here. Okay, horizontal and vertical lines. Okay, so first one, state the slope and y-intercept of the horizontal line L1. L1, that is this guy right here. The y-intercept is 4. Okay, so my b value equals 4. My slope, and this is where we have to remember, a horizontal line, think about steepness. It's not steep at all. It's perfectly flat. It has a slope of 0, right? A horizontal line has a slope of 0. So then it says, okay, well, can you use mx plus b? Well, of course. Y equals 0x plus 4. And then, well, 0 times x, it doesn't matter what x is. 0 times anything is just 0. So really, this thing is y is equal to 4. Okay, no x's, no nothing. It's just y is equal to 4. And that makes sense. On this line, no matter where I travel with the x, I'm always having a y value of 4. 4, y value 4, y value 4, everywhere I go. The x value doesn't really matter. I stay at the same y value everywhere I go. So that's why this equation could be y is equal to 4. Okay. L2, that's this one down here. Well, that also has a slope of 0. So the mx part is gone. 0 times x, it's gone. That thing is at -6. That's where it crosses the y-axis, or that's my b value. Anywhere on this line has a y value of -6. Any point I pick, right? This could be 0, -6. This could be, that's -3, -6, 0, -6, 5, -6. Everywhere you go, y is equal to -6. There it is. Okay, use a graphing calculator to confirm. All right, we can do that pretty quick. Go to your y equals, clear anything out if you have it. Y equals -6. Zoom standard. There it is, a horizontal line. Okay, so my horizontal lines is a y equals, right? We go to the other kind of choice here, a vertical line. So I'm looking at L3. That's this one here. State the slope in the y-intercept. Well, slope of a vertical line was actually undefined. We can't talk about that slope. It's straight up. There's infinite rise. It keeps going up, but there's no run at all. And I know I can't divide by 0. And then the y-intercept, well, there is no y-intercept. It never crosses the y-axis, right? So that's not saying the y-intercept is 0. The y-intercept is 0 would be the origin. There is no y-intercept at all. It doesn't exist. It's not there, right? So why can we not use y equals mx plus b? Well, I don't have a v value, right? So there's nothing for me to plug in there. And my m is undefined, so I can't plug anything into there. So I just can't, because I don't have the proper values. It's impossible for me to clarify those things. Okay? Well, the equation, what I'm looking at is kind of the opposite of horizontal lines. For this L3, the y value goes up and down. I can have a variety of y values, but x is always -3, 0, -3, 5, -3, -5, -3, -2, -3. No matter where I go, x equals -3. So for the start ones, the horizontal lines, it was y equals a number. Vertical lines would be the opposite. It's x equals a number, right? I should have written that down below, but that's okay, right? Well, why can I not use a graphing calculator to verify that? I have a y equals button. I don't have an x equals button. So I actually can't type that in. So we have to know more than our calculator. This is where we have to be smarter than our calculator. And I know that's the correct equation, x equals. Okay, so here it is. This is important to know, all right? The equation y is equal to k, where k is just some number, represents a horizontal line through the y-intercept 0, k, or that, that y value that I keep getting over and over, that flat line, that's where it comes from. The opposite, a vertical line, it goes through the x-intercept at k. X is equal to that value, right? So this would be important. Okay, I think there's a homework question where you kind of deal with that, and we'll look at that during your homework. Okay, last little questions here. It says, determine the equation of a line through the point -2, 8. All right, well, that point is, and maybe drawing a sketch would be kind of useful. Okay, let's call that here. Here's -2, here's 8. It's not the most accurate sketch, but there it is. If I want a line parallel to the y-axis, parallel to the y-axis, that's straight up and down. That's a vertical line, right? So with that, my y values are changing. My y values could really be anything, but no matter what, the x value is always -2. this x value, -2, no matter how high or low I go, that is the guarantee. That's how I can write the equation of the line. Next one, parallel to the x-axis. Well, that's a horizontal line. And that one is the opposite. The x values are changing. I'm going left, right. I'm changing those. But what doesn't change is your y value. Your y value is always 8. It crosses 8 at the y-axis. Your y value is always 8. That's the equation of the line. Okay, so horizontal and vertical lines, yeah, they'll pop up every once in a while. Okay, it's important to know and recognize. Primarily, we're dealing with the stuff from the start of the lesson, right? The diagonal lines, the y equals mx plus b. Okay, and that's it for today. There's your homework, page 565, 1, 2, 4, and 6. And that's all you have to do today. And that is it for this one. Make sure you do the homework. Make sure you ask some questions in the Google form. Set up a one-on-one appointment. Smash the like button. Hit subscribe. Tune in again tomorrow for another video. And that is it for today.